Hello and welcome to the Chandar Academy. In today's video we are going to calculate the following limits. Here we will have limits in plus the infinity of a mix of some sums and subtraction of function that will always go to 1 infinity. This will go to plus the infinity, the 7 we don't really care, and minus the infinity. Here we will have plus the infinity, minus the infinity. And these two things here, if we add and subtract infinities, are undefined form. We cannot conclude just by doing that. But we will use the help of something that is called the compared growth, which is basically saying in plus the infinity, this thing is more, let's say, powerful, that will have more influence than some other thing, okay? Than some other thing. The compared growth. Here we see that we have some polynomials, some constant. We don't really care about constants in plus the infinity. And basically that's it. What you have to know is that the weakest function in plus the infinity, okay, so let's say for very large x, when x tends to plus the infinity, when x is very big, the weakest, so we will have something like that, okay, here we will have the weakest function, and here the strongest. Perfect. The weakest function will be the logarithm function, ln of x, and any logarithms, okay, and any log of x. Then we will have the polynomials, but first the little polynomials, okay, as long x to the a power, as long of course as a is greater than 1 than 0, okay, so for instance we will have x to the 1/2, which is a square root of x, which is x to the 1/2, and as long as the powers are greater than 0, we will keep this order. Here, for instance, I will have x that will be a lot greater than this one. X, then x squared, and then you get it, x to the n, for instance. And then, what do we have? We have exponential functions. A to the x power, of course, with a greater than 1 this time. We have exponential function, and lastly, we have the factorial function, and the strongest of them all is the function that have the form n to the n power. But basically we will use the rules comparing logarithms with some polynomials or some powers of x. Let's start, and also we will use in other exercises the exponentials. Let's start with the first one. We wanted to know the limit a is equal to the limit of, let's say, f of x, when f of x is equal to x to the third plus 7 minus ln of x. Now what we want to do is to factorize by the strongest element in the function, because we have addition and subtractions. Here we see that the strongest element is the x to the third power. This is the more powerful, okay, the most powerful. And ln of x would be very weak. We can just look at the graph here. Ln of x would be very weak in comparison to x to the third. This is equal to x to the third times 1 plus 7 divided by x to the third minus ln of x divided by x to the third. And as x to the third is a lot more powerful than ln of x, this will tend, when x tends to plus the infinity, this will tend to 0. And why can you justify it? You just say that this is because of compared growth. Okay, your teacher will understand that, of course. This will easily tend to 0 when x tends to plus the infinity. This will tend to 0, and this will stay at 1. And we will have something like plus the infinity times 1. And so we can conclude by saying that the limit, so a is equal to the limit of f of x when x tends to plus the infinity is equal to what? Plus the infinity. And we have solved the first part. Now second part, this is really exactly the same thing. Let's call this one g of x for big x, because we are in plus infinity. For big x, for large x, g of x is equal to ln of x minus x to the fifth plus 2. This is equal to x to the fifth times ln of x over x to the fifth minus 1 plus 2 over x to the fifth. This will tend to 0 when x tends to plus the infinity. This will tend to 0. This will tend to 0 when x tends to plus the infinity. You justify it by saying compared growth. This will obviously tend to minus 1. And we conclude by saying that the limit of g of x when x tends to plus the infinity, which is equal to b, is equal to x to the fifth will tend to plus the infinity, of course, is equal to plus the infinity times what? Times the only one resting minus 1, which is equal to minus the infinity. B is equal to minus the infinity. And we have solved the exercise. I hope you enjoyed the video. See you soon. Bye.